Okay, so we are jumping to chapter 11. I don't know what chapter, I guess we were on 6 before. But we're going to chapter 11. Chapter 11 is about conic sections. Conic sections are all of the different things, shapes that you can get by cutting different slices of a cone. So if you haven't already watched the video where the man cuts up the Play-Doh cone, you can watch that and see how you can get a circle, an ellipse, a parabola, and a hyperbola from cutting up a cone. But the first one we're going to do today is the parabola. This is 11.1. Parabolas. We've done parabolas before when we were talking about polynomials and quadratics, but this is another way to look at that and how you can get the points on a parabola without using the quadratic form. And also we'll have parabolas that are up, and we'll also have parabolas that are side to side. But technically what a parabola is and how you can generate the points from it. A parabola is it's a group of points that are equidistant from a single point and a line. Okay, so that single point is going to be our focus, that's what it's called, and we'll talk about that in a minute. And our single line is going to be called the directrix. But before we do that, I'm going to show you a little quick animation of this and how you can see the parabola being made. Okay, so what we have here is we have got our single point and our line, and every point on our parabola is exactly the same distance from this point as it is to this line. So I'll just make it go. We'll hit play and you can watch it. And as it goes, it makes the parabola. It's going to have the exact same distance back and forth. Okay? I could do it one more time if you want to see it again. We have the same distance here and here, and that's going to make our parabolic shape. This one is a parabola that's on its side. We also have some parabolas that are up and down. Okay. So I'm going to draw a parabola and just label all of the different parts of it, the focus, the directrix, and then we'll talk about how you find all that and the equations and things that go with it. Okay, so we'll draw our picture. We'll do our parabola. You can do it up and down, just regular like you're used to seeing. I'm just going to make my vertex on the origin. A lot of the ones we're doing today are going to have the vertex on the origin, but it's not necessary. We will do a couple transformations for graphing. So our vertex is on our origin. I'll just go ahead and just draw a regular parabola here. We're used to seeing those. Then I'm going to label all of the different parts that we'll be finding in this section. So we're going to find our focus, which is inside of our parabola. This is called the focus. Okay? And then a line that's the exact same distance from your vertex or your focus down here, and this line is called the directrix. Okay? The directrix and the focus. So we'll be finding equations for this and for that. Alright. One other thing that we need to know is what the focal diameter is, and this helps us when we're sketching our graph. It is the distance, if you just went straight across your parabola through your focus, from this point to this point, that is called the focal diameter. Okay? So we're going to go through how to find all these things with a parabola that is right or up like this, or it could be down, and then we'll do some side-to-side ones in a second. So we'll do our vertical parabolas first. Okay, so this is the equation that we are given for our vertical parabola. Vertical parabola is x squared is equal to 4py. You'll know it's a vertical parabola if the x is squared. That's what you were used to seeing. if we have a parabola that's this way, it's normally y equals x squared, but in this case, our x squared is equal to 4py. So if we don't have any kind of shifts, our vertex is going to be at the origin. Okay. Our focus is going to be, it's on the y-axis. So it's on the y-axis, so we know the x value is 0. And the y value, we're going to call that p. And we'll be able to find that in a minute using this equation. Okay? So if this distance is p, right here, this little distance is p, then this also has to be a distance of p, because these are equidistant from that point on the vertex. So to find the equation of our directrix is a line y equals negative p, because it's in the opposite direction from our vertex. Okay? And then our focal diameter is 4p. Okay? Some people do the absolute value because it's a distance, but just remember your diameter is going to be a positive difference, like a distance. I guess we could do that just so you can see it. So we're going to do an example now where they give us an equation and we want to find the vertex, the focus, the directrix, the focal diameter, and then we're going to sketch that graph. Just so you can see kind of how this comes into play and how you can find all these things. Alright, so let's see. Our example could be x squared is equal to, let's go with 8y. So we want to try to figure out what p is. So I'm going to look and see what I have that's similar already. I have x squared, good. I've got my y, that's nice. And then I can look here and I see 4p has got to be where the 8 is. So I just make a little equation at this point and say 4p equals 8. So if I want to solve for p is equal to 2. So that's going to help me when I plug in all of the stuff here before I do my graphic. Okay? So I just looked and found what's in front of the y value, set that equal to 4p, and solve it. So our vertex, we didn't have any shifts, it's just the origin. Our focus is the ordered pair 0, 2. P is 2, just plugging this stuff in. Our directrix is y equals negative 2. And our focal diameter is 4 times 2, which is 8. And then I'll sketch it. So once you know what p is, it's really easy to get the rest of this stuff. So we know it was x squared, so it's going to be this way. There's not a negative in there. If we have negative in the problem, it might be upside down. Or it is going to be upside down. So what do I know? Vertex is 0, 0. Okay, good. I'll make the rest of my points. 1, 2, 3, 4. 2, 3, 4. 1, 2. Okay. So there's my vertex. My focus is going to be at 0, 2. My directrix is at y equals negative 2. And my focal diameter is 8. So that means that from my focus, it's a diameter of 8. It's going across 8 in total, which means 4 in this direction and 4 in this direction. Okay? And then you can sketch your parabola. And maybe yours will look better than mine does. Alright? So now we'll do a horizontal parabola and see what the differences are there. This is a pretty long video, I'm sorry. This is a lot of stuff. So my horizontal parabola, if we think about what that would look like, our picture goes like this. We'll have our vertex. I'm going to draw my parabola to the side. I have my focus and my directrix. Obviously it can go the other way, but this is just going to help us to write down all of our stuff. So with this, the equation instead of x squared is 4py, it's going to be y squared is 4px. So if you have the y is squared, it's going to be sideways. Okay, our vertex is still 0, 0. Our focus, let's see, the x value in this case is going to be a p. The y value is going to be 0 since it's on the x-axis. The directrix is going to be x equals, because it's an up and down line, negative p. And then your focal diameter will be absolute value of 4p, just like it was before. So the only difference when you're doing the horizontal versus the vertical is that when you have your focus, the actual p-value is in the x position, and the directrix is x equals instead of y equals. So all your x's and y's are swapped when you're talking about a horizontal parabola. Okay? So if we just wanted to do one real quick, let's say I had y squared equals negative 1/2 x. So if you look at this, the way that it matches up, we know it's going to be horizontal because of y squared. Okay. Also, it's going to go backwards because it's a negative 1/2 instead of a positive in front of the x. So I need to figure out what my p is really quickly. So 4p is equal to negative 1/2. So if I'm trying to get p by itself, I'll divide by 4. So p equals negative 1/8. So negative 1/2 divided by 4 is negative 1/8. So it's going to be pretty small. I can go ahead and write all my stuff down. Vertex, 0, 0. Focus is going to be negative 1/8, 0. Directrix, x equals 1/8. And then focal diameter would be, it's actually just going to be this number that's in the front, 1/2, because that's 4 times an 8 is 1/2. Okay, and sketch it if you'd like, so we can see what that looks like. It's going to be a pretty skinny one. I'm going to make my 1 out pretty far. Okay, alright, so our vertex is at 0, 0. Our focus is at negative 1/8. It's going to be tiny right there. Directrix is x equals 1/8 right there. So you can tell if the directrix is always on the opposite side of your parabola. And my focal diameter is a 1/2, which means it's going to reach 1/2 all the way across. So that would be like a 4th and a 4th. The 4th plus a 4th makes a 1/2. And then, oops, I missed that point. Let's just go back and fix that better. Alright, and there is my parabola. That's very ugly. That's alright. Okay, so I'll show you real quickly how we do transformations, and then we'll figure out how to write the equation if they give us one of these two things, the focal, the diameter, no, I mean directrix, or the focus. So we'll just do transformations. These are easy. Okay, transformations are just like we've done before. If it's with the x value, it's going left and right. If it's with the y value, it's going up and down, and you always do the opposite of it. So if we had one, x minus 4 squared is equal to, let's say, 5y plus 2. Let me put something like this. So you first just figure out how it transforms, and then you do everything else the same. So x minus 4, that's going to go to the right 4. Y plus 2, it's always opposite. We're going down 2. So that just means your vertex is at 4, negative 2. Then you do everything else from that we would have done before. So our vertex is at 4, negative 2. It's x squared, and it's positive, so I know it's going to look like this. That 5 is going to equal the 4p. Divide by 4, so p is 5/4. So you'll use that once you know what your vertex is. So we'll put our vertex at 1, 2, 3, 4, negative 2. We'll go up 5/4 for our focus. down 5/4 for our directrix, and then our focal diameter is going to be 5. So 2.5 this way, and 2.5 this way. There you go. The only thing different with that is first you have to figure out where your vertex is. But after that, once you know what the p-value is, it's easy. P above, P below, 4P across. Unless it's upside down. All right? And now we'll write our equations. When you are writing these equations, the first thing you have to figure out, is this going to be a right side up parabola, or is this going to be a side to side parabola? Is it going to be positive, or is it going to be negative? So that just depends on where your directrix is, where your focus is, and how you can figure that out. Okay? So we'll start with one. They'll just say, right off the bat, write the equation of a parabola, and the focus is 0, -1/2. So they tell us our focus is at 0, -1/2. For all the equations that I'm going to have you do, they are going to be, the vertex is going to be at the origin, just to make it a little bit easier. So I'm just going to sketch that real quick. Here's my graph. I know my vertex is at the origin because they told us that for all of them. And our focus is 0, -1/2. So the focus is inside the parabola. So my parabola looks like that. And my directrix is going to need to be up here. Okay? So if I'm writing my equation, my p-value is -1/2. And I just need to know, is this x squared or is this y squared? So since this is a parabola that's up or down, it's going to be an x squared parabola equals 4py. And we'll just plug the p in. So that's 4 times -1/2 y. So x squared equals -2y. So that is your equation for that parabola. Now let's do one where they give us a directrix. So for this one, they say the directrix is x is equal to 3. So x is equal to 3 for the directrix. So I always sketch that, and I say x equals 3. Okay, 1, 2, 3. That's my directrix. So my directrix is up and down. My parabola is at the vertex. Or my vertex is at the origin, I mean. Directrix is not, the parabola's not going this way. It's going to have to go backwards. Okay. And that's 3 away from my directrix, which means my focus needs to be 1, 2, 3 that way. So my p-value is -3. Okay? Because that's where our focus is, and we can go ahead and plug it in. So since the parabola is side to side, is it x squared or y squared? It's going to be y squared equals 4py. And we're going to go ahead and plug the -3 in for the p. So 4 times -3 times y. Oh, why did I put a y there? This is an x. 4px. Sorry about that. Y squared. So our equation would be y squared equals -12x. Okay? This is a lot of stuff. If you have any questions, let me know. Remember, on your assignment, you have to get 75% correct. So just keep working those. If you get it wrong, redo that problem. Make sure that you can get it before you try another one, so you don't just keep getting problems wrong over and over. Well, I hope you found this helpful, and just remember, ask questions if you need to. Thank you. Goodbye.